All right, so 84, I'm going to work them out on the side. Okay, has 4 terms. I would try to factor by grouping. I can take out a 9x to the third, and I get x plus 3. Take out a positive 4x, and I get x, positive 4x. Wait, this should be x. No, that was right. Yeah, plus, oh, is that a negative? That's a negative. I'm taking out a negative 4x, and I get positive x plus 3. So then x plus 3 and 9x to the third minus 4x looks like this. So now from the one on the right, I can actually take out x, and I'd get 9x squared minus 4. And then this is the difference of 2 squares. So I have x plus 3 times x times 3x plus 2 and 3x minus 2. This is what you should have gotten. Not that. That's 84. Okay. 85. Okay, so I would say a equals x to the third, and then this is a squared minus 7a minus 8. Factor it, a minus 8, a plus 1, and I get positive 8, negative 1. So 8 equals x to the third, and negative 1 equals x to the third. Cube root both sides. And I get 2 equals x, and negative 1 equals x. Sure. So it would have to be x to the third and x to the third. And then you're doing factors of negative 8 that sum to negative 1. So it's still negative 8, positive 1. And then set them each equal to 0. Oh, this, with your factoring, you get different because you get a cube root. Yeah, you would have to factor this from here. So depending on how you do it, that's actually the right way to do it. But depending on how you do it, you either get just those, or you have to do x minus 2 x squared minus 2x plus, nope, plus 2x plus 4. And then you'd get positive 2, and then you use the quadratic on this one. I think because you get 2 different answers doing it 2 different ways, this is not on there. You won't have one where you have to do the cube within the, yeah. Because then this goes x plus 1, x squared minus x plus 1. And then this would be negative 1, but this you'd have to use the quadratic on. So just make sure you know how to factor from the beginning, if it was like x to the fourth and x to the second, I would say. Yeah, Kevin.
Or when you cube root both sides, does it not become plus or minus?
No, only if you square root. So even root both sides is the plus or minus. Okay, 87. So this is similar to the one we just did on the class kick. I have to move one of these over here. So like 2x plus 3 underneath the root would equal 2 minus the square root of x minus 2. Then I want to square both sides. 2x plus 3 equals, and then the shortcut here is square the first one, double the product, so it'll be negative 4 square root x minus 2, and then square the last one, positive x minus 2. I want to combine my like terms. That'd be 2 minus 4 square root x minus 2 plus x. Move all the non-square root things to the other side. So I'd get x plus 1 equals negative 4 square root x minus 2. Now, if I could divide both sides by the negative 4 and it would go in evenly, I would get rid of that negative 4, but you can't. So I'm going to square both sides. This on the left becomes x squared plus 2x plus 1, and on the right is 16. Okay, then distribute this. And then subtract the 16 and the 32. And then there's no factors of that sum of negative 31, that sum to negative 14. So I think the work is out in here, right, to actually work out the quadratic. No, it's not on there. This should be plus 32. Oh, no, it's still. Oh, plus, yes. So then it's minus 11 minus 3. So it's 11 and 3. And then because there's a square root in my initial question, I got to check it. So 2 times 11 plus 3 plus square root of 11 minus 2 equals 2. And square root of 2 times 3 plus 3 plus square root of 3 minus 2 equals 2. 22 plus 3, that's 5, plus this would be 9, which is 3. And I get 5 plus 3 equals 2, which is not true. So that one gets ruled out. And then this would be 6 plus 3 plus the square root of 1 equals 2. And I get square root of 9 plus square root 1. 3 plus 1 equals 2. That doesn't work either. Neither of them worked. Was this no solution? Okay, so 89, if I move the 25 to the other side. Now to get rid of a 2/3, I have to raise it to the 3 halves. And this is that case where I am technically square rooting that. So this has to be a plus and minus. So I get x minus 1 equals plus and minus the square root of 25. So I get plus and minus 5 cubed. X minus 1 equals positive 5 cubed, which is 125. And x minus 1 equals negative 5 cubed, which is negative 125. Add the 1. And x equals negative 124. Okay, and then 91. So these were not on your class kick. Obviously, you still need to make sure that you review this stuff. Okay, least common denominator, and I check, right? This is one that I check. Least common denominator here would be x, and then x plus 2. So from the first one, the x's cancel, and I get 5 times x plus 2. From the second one, it would be 1 times x plus 2. That should not be there, 2. And then the last one, the x plus 2's cancel, and so it's just 3 times x. Distribute. I didn't even need to move the 10. Just going to end up moving it back. Add that. Plus and minus the square root of 10. The only answers that would have been extraneous on this are if x equaled 0 and x equaled negative 2. So both those answers work. Yeah. Would I? You said, or would you? Yeah, sure. Yeah. All right, so the other thing, obviously those were not on what we went over so far doing this full review, is the absolute values with the inequalities were not on the class kick. Remember, those are your less than, and your less than is an and statement, greater than is an or statement. And then the ones like 115, where you're doing what we just did, finding the rational denominator, finding least common denominator, multiplying by it, solving it. But then remember, we have to get it all to one side. It's so blurry. That says 2 over x plus 1 is less than or equal to 3 over x minus 1. So with inequalities, we move them, find a least common denominator, combine them into one fraction, and then set both the numerator and the denominator equal to 0. This is one of those cases, however, though, that it's an or equal to, which would mean typically I would give them brackets. But remember, whatever in the bottom would not get a bracket. So what's going to get a parentheses instead of a bracket would be the negative 1 and the positive 1. So if I actually go to work this out, my least common denominator is x plus 1 and x minus 1. This is missing the x minus 1. 2x plus 2 minus 3x minus 3. Negative x minus 1 in my numerator, which gives me a positive 1, well, negative 1, and then a negative 1, and then a positive 1. When I set up my number line and I test points, I would test 0 because that's the easiest one. Plug it in, and I'd get 2 over 1 is less than 3 over negative 1. Not true. So it would be on the outside, but instead of getting brackets, these are getting parentheses because they were both answers to the denominator, so they cannot be 0. So that you want to make sure you review. I mean, basically everything that's on this stuff, you want to make sure you review. I will fix the answers for the warm-ups from Friday. Hang on 2 seconds, and I'll repost those. All right, so this is the first one. You have to raise both sides to the 3 halves, which means you are square rooting 49 and then raising it to the 3rd power. Because you're taking the square root on both sides, you want to make sure that you do the plus or minus. So that's what a lot of you miss. It's the plus or minus part. So it's plus or minus the square root of 49, which is positive and negative 7, and then cube it, and it's 243. Add the 1, and you should have gotten negative 342 and positive 344. So again, anytime like you are taking the root of both sides and then you're square rooting it, anything that's got an even root in the bottom that you're raising to that power means you are square rooting. So you want to make sure you always get that plus and minus. For 2, it was this one. This is where you want to use substitution. So I want it, anytime I see, again, like 1, it's 3 terms, so that's usually a good indication. But 2, I've got something on the front that's 2/3 and the second one that's 1/3. If the first thing is something squared, which is in this case, I want to use substitution. So I made x minus 1 to the 1/3 equal a, and then I made it a squared minus 5a minus 6. Be careful on this factoring. This is a really common one to make a mistake. People tend to grab 3 and 2, but because it's negative 6 and negative 5, it ends up being negative 3 and, negative 6 and positive 1. Solutions, there would have been positive 6 and negative 1. And then I set it back equal to the x minus 1 cubed, and you should end up with 0 and 216. Yep. You don't have to check these. This was just to check to make sure it works. The original equation doesn't have a square root. It has a cube root, so it's fine. Yep.
Can you go back to the first one?
Mm-hmm. This one, overall, people did pretty good. Just silly mistakes here or there, so be careful. You got to cube both sides of the equation. It literally cancels out your cube roots, and you should have ended up with negative 16 over 5. Again, initial equation is a cube root, so I don't have to check it. This is the 4th one. So you want to, I saw a lot of this, okay? If you're going to square that, that means you're doing square root of x plus square root of x minus 24 times square root of x plus square root x plus or minus 24, which can be done, but that gets messy. It is way better to move one of the roots to the other side, so you're only dealing with one root on either side. So if I moved it and I moved this square root of x, you move the square root of x, you square both sides. And then I also saw a lot of, so if you did it the other way, I think you got like 4 equals, I don't know if it was 4 square root x minus 24. I don't remember what happened there. Something like that. But then I saw this, divide by 4, and this went in evenly. But we went into here, okay? You cannot take something that is outside the square root and divide it into something that's underneath the square root. So that's a big no-no, okay? If I caught it on your work, I'd try to make that note, but please be careful. So with this one, we end up getting the x equals 49. My original question has square roots in them, so I know I need to check it. When you check it, you plug it back in. It does not work. So this would be a no solution. If there were 2, one worked and one didn't, I'd keep the one that works. If obviously there's only one and it doesn't work, then it's no solution. Yep.
You only check it when it's a square root.
If it starts as a square root, yep. Or there's a variable in the denominator, because those were on your review. Well, that's when I go over the answers, I'll go back to that one. Or if it was an absolute value equal to polynomial, like an x squared plus something like that. All right, then this last one, so I want to get it all to one side. I would try to factor it if it was factorable. This one was not. I used the quadratic to get 1 plus or minus the square root of 33 over 4. So I don't need to know exactly what that is. I just need to know that 1 would be left of 0, 1 would be right of 0. And then I plugged in 0. It worked, which means I shade in between. This is an or equal to, so you make sure to give it the brackets, okay? Some of you either just found the answers and left it, didn't leave it in interval notation, and some of you used parentheses, so be really, really careful. Yeah. Go back to 2.